All right. In our last few videos, we've been talking about these parallel lines cut by transversal, just like this. Parallel lines cut by transversal, parallel lines cut by transversal, and all the relationships that they create. Can we go backwards? That's what our lessons today are all about. So if you turn with me to page 10, I believe, no, maybe page 11, we're going to go ahead and do some of these backwards. Let's go to this problem first. Now, let's suppose that these two lines are not parallel. Take a look at the two lines in our thing, T and M. They are not parallel. If they're not parallel, they will have to intersect at some point. It doesn't matter how close it is or how far it is, but they're going to intersect at some point, which means they'll make an angle. We'll talk about that angle in just a second. But they are not parallel. Okay? Can we still have corresponding angles that are congruent if our lines are not parallel? In other words, is this 120 degrees going to be the same up here if the lines are not parallel? Well, let's go ahead and go through it. The first thing to note is that even though those lines aren't parallel, that doesn't mean I can't draw a set of parallel lines. And that's what line L is compared to M. Those are parallel. So now I've got two parallel lines, which means I've got some corresponding angles. Angle 1 and the 120 degrees, those are corresponding, which means they are congruent. So this is also going to be 120 degrees. Awesome. Now that's really good. If this bigger angle, it looks bigger, is still 120 degrees, then corresponding angles can be congruent no matter what kind of lines we have. But if it's not 120 degrees, we know that it can only be congruent if we have parallel lines. So let's go ahead and see if we can find out how big that remaining angle is. Now I told you before that since lines T and M are not parallel, they're going to intersect, and they will intersect and make this angle. We're just going to call it X. We don't know what it is. If it's super duper far away, like 30 miles away where they intersect, maybe the angle's real small. If it's 2 feet away, maybe the angle's pretty big. Regardless as to what it is, because they're going to intersect, that angle X has to be greater than a certain value. That angle exists, and it's not going to be 0. It's got to be bigger than 0. Okay, so whatever X is, we know that it's bigger than 0. But X actually compares to angle 2. Take a look at angle 2 and angle X. Those are alternate interior angles between our imaginary parallel line and our original parallel line. Okay? So that means angle 2 is X. And we know that angle 1 plus angle 2 make up our corresponding angle. Now these are still called corresponding angles even if the lines aren't parallel because they're in the same location. Are they congruent though? Well, let's take a look and actually add them. We got 120 degrees plus X degrees. Now if X was 0, then this would be congruent. But we decided back here that X had to be greater than 0. If there's going to be an intersection, X got to be greater than 0. It could be 0.000001, but it's not 0. It's bigger than 0. So since 120 plus X has to be greater than 120, since X is not 0, then the corresponding angles are not congruent. So corresponding angles are not congruent. Okay? And that brings us to a pretty simple conclusion. If our lines are not parallel, then the corresponding angles cannot be congruent. In other words, it kind of gives us a backwards statement. Our original statement was that corresponding angles make parallel lines. And our backward statement goes like this. Or, as you've learned in the last chapter, our backward statements have names. Okay? Our backward statement would go like this. If corresponding angles are not congruent, then the lines are not parallel. Okay? This is an if-then statement that's a little bit different than the ones that we've encountered so far. Okay? This includes some nots. This is the negation statement. But the negation is the same way as saying what's called the converse. Okay? So now we're going to state the converse. If corresponding angles are congruent, then there are a set of they are in a set of parallel lines cut by a transversal. Okay? If corresponding angles are congruent, then they're in a set of parallel lines cut by that transversal. Okay? Now, it's a pretty simple statement to use. We're going to go through a few proofs that kind of follow from this, but what we just did was called a proof by negation. We proved that it was impossible for the corresponding angles to be congruent, and we came up with the opposite statement. This is a proof by negation. We showed that it was impossible for it to be untrue. Okay? Now, finally, that leads us to the converse statement. I want you guys to understand that this is the converse. Okay? The converse statement is just the backwards. We had the previous statement, if we've got parallel lines cut by transversal, then corresponding angles are congruent. This one is if we've got corresponding angles cut that are congruent, then they're in a set of parallel lines cut by a transversal. Okay. So can we use that to prove alternate interior angles? Yes, we can. Let's do it visually, then we'll do it in writing. I'm going to go a bit faster than I have in the past, but this is part of our expected understanding to be able to give statements with our reasons. So we're going to go ahead and do that. Take a look at angles 1 and 2. These are alternate interior angles. Do alternate interior angles being congruent imply that the lines L and M are parallel? Let's go ahead and find out. If angle 2 and angle 1 are congruent, what else do we know? Well, that tells us that angle 3 is congruent to angle 1 because these are vertical angles. And angle 3 and angle 2 are now corresponding angles that are congruent. Wait, corresponding angles that are congruent mean the lines have to be parallel. So those are our statements. We're going to go ahead and write them here. Given, we're going to say angle 1. Oh, let me make this back to its original thickness. Angle 1 is congruent to angle 2. All right. And then statement number 2, angle 1 is congruent to angle 3. Okay. Now take a look at those two statements. Remember, a proof is a logical reasoning step. So you want to see, how do these two statements lead to this statement? Oh, yeah, angle 1 is congruent to each of those. So since it's congruent to both of them, they're really congruent to each other. Again, that's the transitive property, or you can just say they're both congruent to angle 1. Awesome. So since angles 2 and 3 are congruent, we have corresponding angles that are congruent. What does that tell us about our parallel lines? They are congruent as well. Okay, and we'll say corresponding angle converse. Okay, awesome. That's our proof. Now I want you to go ahead and try this proof out. Okay, use the proof that we just did and see if you can prove that these two congruences, or that these two angles being congruent, lead to parallel lines. Again, the two previous statements that we came up with are actually true now. The first one is that corresponding angles, if two angles are congruent, corresponding angles are congruent, then the lines are parallel. And our next one is the one that we just used. If alternate interior angles are congruent, then the lines are also parallel. So those are the things that we can use. I want you to try to go through and fill out this proof. We've got angles 2 and 1 here. Those are not congruent. They add up to 180. So since these two add up to 180, see if you can find out how to prove that the two lines are parallel using these statements and reasons. Finally, you can do a little application by trying to apply them here on these two examples and try it problems. Go ahead and do that if you can, and I will see you next for the big idea 2C. Actually, I want to finish writing up our big idea 2B statements up above before we go on to big idea 2C.